Alright, so let's solve an example. First, let's write down the problem. Okay. Determine the carburizing time. So as I said, it's a heat treatment that introduces carbon into the material. Carburizing time necessary to achieve a carbon concentration of 0.45 horrible 45 weight percent at a position 2 millimeter into an iron carbon alloy that initially contains 0.2 weight percent of carbon. So it gives us what is the concentration at a certain distance, and we are asked to calculate the time, and it also gives us the initial concentration. Okay. The surface concentration is to be maintained at 1.3%, and the treatment is to be conducted at 1000 degrees C. My writing is horrible, but then it's because of I'm writing on the iPad. Okay, so 1000. So we are given the temperature. So use table 5.2 for gamma iron diffusion to get the diffusion data. So you guys need to look at the table, your book, and then read the numbers. Okay, let's see. So we have basically a steel iron carbon alloy. The carbon is going to diffuse. We are given information about the position, right? 2 millimeter depth. The concentration is 0.45%. The surface concentration of the carbon is 1.3, and initial concentration is 0.2%. Okay, and the temperature is given 1000, and that's it. And of course you understand this is Fick's second law problem. There is time, and therefore all we have to do is look at our equation, plug in the numbers, be careful with the units, and then calculate the time. That's it, because in the equation the time is there, so we can calculate the time directly from the Fick's second law equation. So we gotta remember our equation was concentration at a person some time, some distance minus the initial concentration over the surface concentration minus initial concentration 1 minus error function x over 2 square root dt. And time is in the equation. So if I solve this equation for time, I should be able to basically solve it. And C naught, we are given C naught, right? We said it is 0.2. So I go in and put in the number. C naught is 0.2. This is 0.45 minus 0.2 over 1.3 minus 0.2 is equal to 1 minus error function x over 2 square root dt. And let's find out the value of error function. Okay, let's do that. So the next thing you need to do is look at the table 5.1, and you should read this information. So for the value of inside, if this is overall z, right, this term, what is the corresponding error function? So we are seeing that from the table for 0.885, the error function is 0.7707. For a value of 0.9, the error function is 0.7970, and our number is in between. We have 0.7727. What is the corresponding z, or this term, right? So all you gotta do is do linear interpolation here. So it is z minus 0.85 over 0.9 minus 0.85 is equal to 0.771. Okay, so there is no space left. So this is equal to basically, right, 0.7727 minus 0.7707 over 0.7970 minus 0.7707. And from here you calculate z, and it should be 0.854. All right. So we found inside the error function is 0.854, which is x over 2 square root dt. And we know what x is, right? We know the x is given to us 2 times 10 to the power of minus 3 meter. We are asked to find this. Now there is this problem, right? We gotta figure out what the diffusion coefficient here is. So you need to remember what is the equation for the diffusion coefficient. And now how you gonna find D naught, how you gonna find Q is from table 5.2, and we know this is 1000 degrees C, which is 1273 Kelvin. R, we know it is 8.31 joule per mole Kelvin. So we need to read Q and D naught from the tables. For a gamma iron, the diffusing species are carbon. So if you read that information, this is what you get. Okay, D is equal to D naught, you read from the table, in units of meters square per second. exponential term, you read the activation energy to be 148,000 joule per mole over 8.31 times 1273 Kelvin. This is Kelvin, this is joule per mole Kelvin. Alright, so you calculate the diffusion coefficient to be this. Okay, so now we know the diffusion coefficient. I can plug this in here and then I can calculate what the time is. So basically with all these information, with the system given, concentrations given, you are able to calculate the time requires at a depth of 2 millimeters. What is the concentration of carbon you expect, right? So that is also given to us already, just at that time, right? For that time frame. So let's calculate the time. All I have to do is plug the information in, that's it. And be careful with the units because all units have to be the same, right? So as I always say, you guys don't need to memorize formulas, but you need to understand how things work in the formula. And what do we do, why do we do it, what is asked, how do we approach to solve what is asked. And if you follow these problems solving techniques I'm teaching here, then you should be able to easily solve any problem. So we calculated the time to be 19.7 hours. Good. That's how much time it takes. Okay.